Hi everyone, welcome to this session. So in this session, we'll design the ISM band antenna using ADS software. So the frequency which we have considered for ISM band antenna, that is 5.8 gigahertz. Okay, so ISM is nothing but your industrial, scientific and medical applications. Okay, so the frequency which we have considered is 5.8 gigahertz. That only we will use for our center frequency, you can say, or you can say the frequency of operation for this patch antenna. So in the layout only, we're going to design this patch antenna. So I'll create a new layout as of now, which is says as ISM, suppose ISM antenna, let's say. Okay, and once it will be formed, my workspace will be ready. I'll keep it aside a little bit. Okay, now next is to, just like in other antenna steps as well, we will go for the insert rectangle and we'll do some random designing of the rectangle. Okay, so that we're going to design, and further I'll design for one, you can say for one for feed, one rectangular for feed, and one rectangular that I'll use later on, as you will see in this. Okay, so now we will define the width and length for this patch basically. So once you'll click on, in the right side you will get a property window. In that, under the width, you will mention it as 18 mm and height will be 17 mm. So height is nothing but your length, we can consider that is your length, you can say. Okay, so just like in other EM tools, we are designing this patch antenna having width and length. So here height you can consider as length itself. Okay, now next is my feed. So width will be just like the same conventional we are going to design, that is 3.11 for this design for this FR4. Width will be 3.11. Okay, and sorry, width will be 1.5, not 3.1. Actually, it was for different design. And the height, that is the length, will be the 11 mm. Okay, so this will be your 11 mm. Okay, now this rectangle, how we will use, because we are using a inset feed designing, inset feed patch antenna. So an empty space we will create it over the patch lower edge. Okay, so click on this and go to the width. Width will be, so insert feed, as you know, the insert is 0.4 width, correct? So 0.4 width, but it is 2 on number on 2, so 0.4 plus 0.4, it will be 0.8, correct? And the width of this feed is 1.5. So total width of this rectangle, by which I'll going to create a vacant place, or you can say the intersection, it will be 2.3. Okay, so 0.4 plus 0.4 plus 1.5, it will be your 2.3, correct? And length, so length of the insert is 6 mm. So I'll write the height as 6 mm. Okay, in this way you can design. Okay, now what I'll do, I will select this and I will use this option, that is move using a reference point. So I'll take the lower edge point and I will select this one, correct? And I will now, once it is placed correctly, what we can do, we can subtract this shape from this patch. Okay, how you can do this, just select this patch and select this feed, go to edit, in the merge use this operation union minus intersection and you can click OK, correct? Now this is vacant place is created now, and now we are having a sufficient space for the insert as well as our feed as well. Okay, Now what you have to do, just click on this. Okay, sorry, before you have to select this feed as well, and then click on this and then select the midpoint. Automatically it will activate the midpoint and go to this. Okay, make sure if you are not suppose if you are not, in case if you are not able to select this midpoint of this edge or anything, make sure these snap mode is activated. So this is snap mode for selecting the midpoint. So if it is not activated, then I can't select the midpoint of either this patch or this edge or this even feed. Okay, now select again both the things and go to edit, go to merge and union. So it will be my one element now. Okay, now second task is to place your pin so that we can see the results. Okay, means P1 is nothing but your port itself. Okay, now next task is to set up your electromagnetic simulations setup. Okay, now as we know that we are using a 580 dielectric, or you can say the substrate for this design, that is Rogers RT Durite 580, which consists of the dielectric constant is 2.2. Okay, so that is low dielectric constant having low loss. So click on create EM setup and click OK. Now go to the substrate. As you can see here, one error is there. That's why under the momentum microwave, it is showcasing an error, or you can say the warning itself, because no substrate means no dielectric, and hence you can't simulate the result of this antenna. Now in order to set up the substrate, go to this new, because we are not having any substrate, no valid substrate found, as you can see here. So we have to define a new substrate for this. Now I'll name it as Rogers 580, suppose, because Rogers will have a different or you can say the variant substrate as well. Okay, so in that case, what it is good to define specifically. Now select the ground layer and locate it as copper, maintain as 35 microns, that is 0.035 millimeter. Okay, so coming on to this conductor also, it is copper itself, and thickness is 35 microns. Substrate, if you will click on this side, it will be nothing but substrate, and this will be nothing but your plane only anyway. So we need to define this substrate. As of now it is alumina, but we need a Rogers RT Durite, so you have to select this 580. If it is not applicable, if it is not visible in your system or in your software, then what you have to do, go to this option, edit materials. Under this edit material, add from database, and you have to search among this list of this materials. Okay, so I hope it is easier for you to define. Okay, now click Control S and wait a second, it is not having a proper dimension for the thickness. So thickness which we are going to consider is 0.508, which is near about to 20 mil, I guess, but I will use it in a millimeter way unit. Okay, so that is my substrate now, Rogers RT Durite, having this 0.508 millimeter thickness. Okay, and the conductor itself which we are using is copper anyway. So I'll click cross now and I'll go for ports, I'll go for frequency, and frequency is 1 to 10 gigahertz. I'll start with and I will add one more frequency plan so that I can see the results actually. So it will be single frequency, that is my center frequency, which is around 5.8 gigahertz. Okay, why it is 9 hour obviously. Okay, anyway, so 5.8 gigahertz it has been simulated, and I can use the save currents all generated for frequencies. So whatever the currents means, field distribution surface current can be stored for all generated frequencies anyway. Okay, so in this way you can simulate this design, and once I'll click on Ctrl+S, it will save this EM setup for this design. Okay, so I'll click on simulate. Now once you will simulate, it will simulate it within a second, and actually since it is very easier to simulate in ADS, As you can see here, results are already simulated now, and it is my S11. Anyway, it is not required anyway, so we'll focus on this part. So this is S11, or you can say the return loss, which is in frequency in gigahertz, and this is in S11 in dB value. Or what I'll do, I'll plot it again. Actually, it is not showcasing in a proper way. Okay, so it is dB, and if you want to see the lower value of curve, just go to this marker and select this valley marker. Valley means your minimum point of it. So it's giving around 13 dB of data loss, and it is 5.8 gigahertz. I'll also suggest one thing. If same design, if you will do in perform in other tools, then you will get more better actually, because in this case of a tool it is using a MOM, but in case of FIT or FDTD, just like in case of other tools, that it will be much better anyway. And those who have participated in my courses, so they know already that what was the what was the impedance as well as the S11 for this design. So I hope you enjoyed this session and you got this designing part. Okay, thanks a lot. Thank you so much.